Welcome back to Chemistry Exams Prep. This is Dr. Kulbhushan. I have another interesting question for you. This question was asked in last year's NEET exam, but this type of question is also very important for other undergraduate exams and also for MCAT. In this question, we need to figure out the identity of product P. So this is a reaction of an alcohol in presence of hydrobromic acid. So here this is a secondary alcohol. So this is called our substrate. So we have a secondary substrate here. Meth, eth, prop, but. So we have a substituent at carbon number 3. Therefore, it's 3-methyl-butane 2-ol as the alcohol is at carbon number 2. So it's a secondary alcohol. So in this substrate, the functional group is the OH, where the oxygen has 2 lone pairs of electrons. So this acts as a base here. We know that HBr, which is the reagent here, so the reagent is a very strong acid. So the first reaction, no matter what the product will be, is the acid-base reaction. So the first reaction must be ROH plus HBr. This would give you protonated alcohol plus bromide ion. So in the first reaction, if you want to see the mechanism, the lone pairs of electrons on oxygen, one pair would approach the proton and the HBr bond breaks to give us protonated alcohol. So this protonated alcohol now has a good leaving group. OH is not a good leaving group, but H2O is a very good leaving group. Now the second species that is formed in this first acid-base reaction is formation of bromide ion, which is a weak conjugate base. It's a weak conjugate base because HBr is a strong acid, so its conjugate base is a weak base. Now Br negative is also a good nucleophile. The reason for that is that Br's polarizability is very high, which means that it can form a covalent bond with a carbon easily, and its electronegativity is much lower than other two halogens, fluorine and chlorine. Therefore, this is a good nucleophile. So the reactions of alcohols are two important reactions. The first is substitution reactions and the second is elimination reactions. So there are these two possibilities here, that there could be a substitution reaction or an elimination reaction. If substitution occurs, these three possibilities, 1, 3 and 4th are the choices. If an elimination occurs, then choice 2 would be the answer. So the elimination reactions are actually favored at high temperature. Because at high temperature, the entropy is favored as the one alcohol molecule is converted to two molecules, alkene and water. Therefore, if the temperature is higher, the alkene formation would be favored. But in current case, the temperature is not given, so it's considered that it's at room temperature. Therefore, the possibility of elimination is not here, so we can eliminate choice 2 here, and so therefore the possibility is a substitution reaction. Now in substitution reaction, once we have a good leaving group, there are two possibilities. There could be SN1 substitution, which is through carbocation intermediates, or there could be SN2 mechanism, which is through transition state. Now we know that if there is a tertiary substrate, then the mechanism would be through carbocation formation, SN1 mechanism, substitution nucleophilic first order. And if there is a primary substrate, then the mechanism would be through substitution nucleophilic second order, because the primary substrate is less hindered so the transition state is easy to form, and therefore if there were to be a primary alcohol, then the mechanism would be SN2 mechanism here. But there is a secondary alcohol substrate here. So the secondary alcohol substrate can undergo either SN1 reaction or SN2 reaction. Now, if there is a possibility of rearrangement, means if the carbocation can convert from a secondary carbocation to a tertiary, then the mechanism would definitely be through SN1 mechanism. In this case, a secondary carbocation forms, which can convert to a more stable tertiary carbocation by hydride shift. So the carbocations rearrange, and that's one of the most important properties of the carbocations. So once you form a more stable tertiary carbocation, this is planar, and the nucleophile now can approach from either side of this planar carbocation intermediate to give us the product tertiary alkyl halide. So which means that choice A is the correct answer there. Now if there is no chiral carbon here, as there are two similar groups here, same groups here, two methyl groups, but if there were to be one different group, then in this case a racemic mixture would be formed, which is about 50-50 of R and S isomers, which is known as a racemic mixture. Now the choice 3 is not the correct choice, because this is the product, this secondary alkyl halide is the product of the secondary alcohol, which does not undergo the carbocation rearrangement. So that's not the correct answer. And choice 4 is also not correct, because it shows the product of a primary carbocation substrate.